Alaska Airlines Flight 261 is falling from the sky. Both pilots exert all their strength to pull back on the control columns, fighting to level the aircraft as it rapidly loses altitude. Screams echo through the cabin as the aircraft dives toward the ocean. Passengers experience intense G-forces and loose objects fly upwards, hitting the ceiling. After descending approximately 7,000 feet in just 80 seconds, the crew manages to arrest the rapid descent, leveling the aircraft at around 24,000 feet. However, the problem that caused the dive is far from resolved, and another freefall looms. The situation is dire, with the crew physically exhausted and the aircraft barely controllable. Can the pilots prevent another dive toward the Pacific Ocean and manage to land the aircraft safely? This is the story of Alaska Airlines Flight 261. It is January 31, 2000. It's a beautiful day as Alaska Airlines Flight 261 is being prepared for a journey from Puerto Vallarta International Airport, Mexico, to Seattle-Tacoma International Airport, United States, with an intermediate stop at San Francisco International Airport. In the afternoon, 83 passengers and 5 crew members step on board a McDonnell Douglas MD-83. The aircraft, manufactured in 1992 and delivered new the same year, is a longer-range version of the original MD-80. It features higher weight allowances, increased fuel capacity, and more powerful Pratt & Whitney engines. Before today's flight, the aircraft has logged almost 27,000 flight hours and over 14,000 cycles. Departing from Puerto Vallarta International Airport, the flight heads northwest over the Pacific Ocean before entering U.S. airspace. It continues along the California coastline before descending into San Francisco International Airport. The estimated flight time to San Francisco is approximately 4 hours. After a brief stop in San Francisco, the flight continues north to its final destination, Seattle-Tacoma International Airport, with an additional flight time of around 2 hours. The pilots of Flight 261 are both highly experienced. Captain Ted Thompson, 53 years old, has logged nearly 18,000 flight hours with over 4,000 hours on the MD-80. First Officer William "Bill" Tansky, 57 years old, has accumulated more than 8,000 total flight hours, with most of his experience as a first officer on the MD-80. Thompson has flown for Alaska Airlines for 18 years and Tansky for 15. Both pilots have spotless safety records and previous military experience. Thompson in the U.S. Air Force and Tansky in the U.S. Navy. 3 Seattle-based flight attendants complete the 5-person crew. Despite its crew's experience and dedication, Alaska Airlines faced significant operational and financial challenges. In the year 2000, the airline extended the maintenance intervals for some of its aircraft components to cut costs and improve operational efficiency. By reducing the frequency of inspections and servicing, they aim to keep their fleet in the air longer, maximizing revenue and minimizing downtime. The Federal Aviation Administration, or FAA, even approved these extended intervals, giving the airline confidence in their new maintenance schedule. However, what seemed like a strategic move for efficiency would soon reveal unforeseen challenges that would test the very limits of their operations. At about 2 p.m. Pacific Standard Time, Alaska Airlines Flight 261 begins its journey. As it gets pushed back from the gate, the pilots start the engines and taxi toward the runway. The weather conditions are ideal with light winds and clear skies. After a short taxi, the first officer positions the aircraft on the runway, and seconds later, the crew receives clearance for takeoff. The first officer moves the thrust levers forward, and they accelerate down the runway, lifting off shortly after. While passengers enjoy the clear skies and stunning views, a serious problem is developing in the aircraft's horizontal stabilizer, located at the tail of the aircraft. The MD-83 features a trimmable horizontal stabilizer, which adjusts the aircraft's pitch by tilting up or down. This component alters the pitch attitude without continuous pilot input, significantly reducing pilot workload and aiding in maintaining a steady flight path. The trimmable stabilizer is crucial for balance and control during various flight phases. The movement of the stabilizer is controlled by a jack screw mechanism, where the rotation of the jack screw through a fixed Acme nut causes the stabilizer to tilt up or down, adjusting the stabilizer's angle. Climbing through 23,400 feet, the autopilot struggles to adjust the stabilizer, causing a warning light to appear in the cockpit. Unbeknownst to everyone on board, excessive wear on the stabilizer's jack screw and Acme nut, unnoticed due to extended maintenance intervals, has caused the stabilizer to become jammed and stuck at a slight nose-down angle due to increased friction and reduced effectiveness of the threads. What starts as a seemingly perfect flight is about to turn into a nightmare as the aircraft's hidden mechanical issues begin to surface. The aircraft continues to climb, but at a slower rate. The pilots decide to manually control the aircraft and disconnect the autopilot, requiring up to 50 pounds of force on the control columns. Despite the increasing difficulty, they reach their cruising altitude of 31,000 feet, and the amount of force needed on the control columns is slightly reduced to about 30 pounds. For the next 2 hours, the crew wrestles with the unresponsive stabilizer. They attempt a variety of methods to regain control. Initially, they try using the pickle switches, which operate the electrical motors in the tail, but these prove ineffective. Next, they attempt to use the longitudinal trim handles, commonly called suitcase handles, and even operate both mechanisms simultaneously. Unfortunately, these efforts do not yield any results. The crew then switches to the alternate trim system, which relies on a different motor. However, this system also fails to move the stabilizer. They check the circuit breakers, hoping an electrical fault might explain the issue, but all breakers are in their normal positions. Despite their persistent efforts, the stabilizer remains stuck at 0.4 degrees nose down, leaving the pilots to exert substantial manual force to maintain control of the aircraft. At 3:46 p.m., they re-engage the autopilot, hoping for relief, but the problem persists. As they continue troubleshooting, the flight crew becomes increasingly aware of the seriousness of the situation. Captain Thompson and First Officer Tansky coordinate their efforts, referring to their checklists. Despite their experience, the unresponsiveness of the horizontal stabilizer creates a significant challenge. The stabilizer, still stuck at a slight nose-down angle, forces the pilots to exert considerable manual force to keep the aircraft level. Despite their efforts using the primary and alternate trim systems, the stabilizer remains unresponsive. Each attempt to adjust it results in no movement, hinting at a deeper mechanical issue that the pilots have yet to fully comprehend. Unbeknownst to them, their attempts to fix the system only worsen the situation. They will soon come to realize the full extent of this critical failure. In another effort to resolve the issue, the pilots contact Alaska Airlines Maintenance Control in Seattle. They report the jammed horizontal stabilizer and discuss the possibility of diverting to Los Angeles International Airport. The conversation is tense, with the captain emphasizing the need for a safe landing. The maintenance team suggests several troubleshooting steps, but nothing resolves the issue. Maintenance Control asks why the pilots prefer Los Angeles over San Francisco. The captain explains that Los Angeles typically offers better weather conditions, which could be critical for a safe landing given their control issues. He mentions that dry runways and favorable wind conditions make it a safer choice than San Francisco, where rain and wind might complicate the landing. Despite the captain's clear preference for safety, the dispatcher mentions the operational flow at Los Angeles, hinting at potential delays. The captain, frustrated by the focus on scheduling rather than safety, emphasizes the severity of their situation. They decide to divert to Los Angeles, prioritizing the well-being of everyone on board. Around 4 o'clock, a mechanic from Alaska Airlines LAX maintenance facility joins the radio communications, asking if the crew has tried the primary and alternate trim systems. The captain confirms they have, but with no success. He describes how the primary trim motor causes a spike in the electrical load, indicating that the motor is trying to work but is obstructed by something. Meanwhile, the alternate trim motor shows no response, further complicating their situation. After the conversation with the mechanic, the captain decides to disengage the autopilot once more, hoping to manually adjust the stabilizer. A clunk is heard as soon as the autopilot is turned off, followed by 2 faint thumps. At this moment, the jack screw mechanism that controls the horizontal stabilizer fails completely. The worn threads of the Acme nut can no longer hold the jack screw in place, causing the stabilizer to shift abruptly from a slight nose-down position to a full nose-down angle. The sudden shift in the stabilizer angle forces the aircraft into a sharp dive. Inside the cockpit, the pilots struggle to regain control, battling against the overwhelming downward force as the aircraft's nose remains pitched downwards aggressively, creating a terrifying situation for everyone on board. The passengers continue to experience intense G-forces as the aircraft plummets toward the ocean, and loose objects in the cabin fly upwards, hitting the ceiling. The scene is chaotic with alarms sounding and the pilots working urgently to stabilize the aircraft. The pilots must now exert extraordinary effort to counteract the mechanical failure and bring the aircraft back to level flight. They deploy the speed brakes in an attempt to slow the aircraft down and with all their strength pull back on the control columns with up to 140 pounds of force. 80 seconds after the dive started, the pilots managed to arrest the rapid descent, leveling the aircraft at approximately 24,000 feet. However, the horizontal stabilizer remains jammed in a nose-down position, requiring continuous effort to keep the aircraft from diving again. The situation is dire, with the crew physically exhausted and the aircraft barely controllable. Realizing the extent of the problem, the pilots request a block altitude from air traffic control, allowing them to operate between 20,000 and 25,000 feet without worrying about other aircraft. This altitude buffer provides some safety margin as they continue troubleshooting. The stress in the cockpit is intense, with the pilots exchanging urgent, clipped commands. The captain then decides to contact maintenance control again, reporting the full nose-down trim position. The mechanic acknowledges the seriousness of the issue but offers no new solutions. The crew is essentially on their own, flying above the Pacific Ocean, battling a malfunction that threatens their lives and those of their passengers. After the aircraft is somewhat stable again, the captain makes an announcement to the passengers, informing them of the flight control issues and the decision to divert to Los Angeles International Airport. He reassures them they are doing everything possible to ensure a safe landing. The passengers, though frightened, find some comfort in the captain's calm voice. As the aircraft nears Los Angeles, the pilots prepare for landing. They plan to slow the aircraft and test the control response at lower speeds, hoping to find a stable configuration for the final approach. Given its compromised state, they must determine if the aircraft can be safely landed. The captain instructs the first officer to extend the slats. The aircraft remains stable, encouraging the pilots to proceed with further preparations. He then commands an 11 degrees flap deployment. The aircraft continues to hold steady, but then the captain instructs the first officer to retract the slats and flaps. He wants to make one more attempt to get the stabilizer to move. After discussing it with the first officer, they decide against it and choose to begin their landing approach. However, the situation takes a critical turn. Under immense aerodynamic pressure, the stabilizer finally gives way. The jack screw, now unable to engage properly with the stripped threads of the Acme nut, allows the stabilizer to move uncontrollably. This unrestrained movement causes the stabilizer to oscillate violently with the airflow. The intense forces acting on the stabilizer become too great, eventually causing the stabilizer's tip fairing brackets to pop off, leading to an abrupt shift in the stabilizer's position. The aircraft pitches violently nose down, entering another steep dive. Now fighting against gravity and a compromised aircraft, the pilots struggle to regain control. In a desperate move, the captain decides to invert the aircraft, hoping that flying upside down will give them a chance to stabilize the pitch. The maneuver works temporarily, with the aircraft's nose rising, but the structural damage and extreme forces make it clear that this solution is not sustainable. As the aircraft speeds toward the ocean, the pilots make one last effort to save their aircraft. They attempt to roll the aircraft back to an upright position, but the intense forces and mechanical strain cause the situation to worsen. The engines, now struggling to cope with the extreme angles and airflow disruption, start to stall. The aircraft loses power and with it any remaining control. Despite the pilot's best efforts to correct the aircraft's orientation, the control surfaces are unresponsive and the aircraft remains inverted. The pilots execute a series of commands in a final bid to regain control. They push and roll, trying to right the aircraft, but the forces are too great. With each passing second, the ocean looms closer as the aircraft's speed increases. Ultimately, the first officer makes a mayday call but does not transmit it over the radio. After trying everything they can, the aircraft impacts the water at approximately 4:21 in the afternoon. The impact is devastating, breaking the aircraft apart. The force of the crash is so severe that there are no survivors among the 88 people on board. Debris scatters across the surface of the ocean, marking the tragic end of Alaska Airlines Flight 261. Pilots from nearby flights report seeing the aircraft plunge into the ocean, and their radio transmissions quickly alert air traffic control to the disaster that has just occurred. In the aftermath of the crash, a massive search and recovery operation was launched to locate the wreckage and retrieve the flight data recorder and cockpit voice recorder. The search area was approximately 2.7 miles north of Anacapa Island, California. After several days of intensive searching, the wreckage of Flight 261 was located on the ocean floor. Search teams meticulously combed the debris field using remotely operated vehicles, eventually recovering the flight data recorder and cockpit voice recorder. These devices were sent to the National Transportation Safety Board for analysis. The investigation revealed that the primary cause of the crash was the failure of the horizontal stabilizer jack screw assembly, which experienced excessive wear due to insufficient lubrication and extended maintenance intervals. This wear caused the Acme nut threads to degrade severely, leading the jack screw to jam initially. Under continued aerodynamic forces, the stabilizer assembly ultimately failed completely, causing the stabilizer to move uncontrollably, resulting in the aircraft entering a fatal dive and crashing into the Pacific Ocean. The tragic loss of Alaska Airlines Flight 261 underscored critical maintenance practices and regulatory oversight issues, leading to significant changes in aviation safety regulations, including stricter maintenance schedules and improved inspection protocols for critical components. In recognition of their efforts, Captain Ted Thompson and First Officer William Tansky were awarded the Airline Pilots Association Gold Medal for heroism. Their attempt to regain control and efforts to minimize the impact showed great courage and professionalism, likely preventing a greater disaster on the ground. This concludes our investigation into Alaska Airlines Flight 261. If you'd like to stay updated on our latest investigations, don't forget to subscribe to our channel and leave a like if you found this video informative.